Hi, everyone. Thanks for choosing to spend the time with me today. My name is Viorel, and today I'll be talking about how I use DevOps tools and techniques to build a testing lab. I will show you how I deploy from scratch an environment that I will later use to create a SQL Server availability group. A few words about me. I live in Belgium, in sunny Belgium. I'm a SQL Server consultant, and for many years I've been a production DBA. Lately, I find myself doing a lot of automation around databases and infrastructure. You have my contact details on the screen, and if you have any questions for me after the session, feel free to reach via social media or send me an email. Let's go over to the agenda. So today's goal is to build a SQL Server availability group, right? So although this task can be accomplished in many different ways, I chose to do it like this because I find it that is very flexible. You can use the same approach if you are working on-prem or in the cloud. And the tools I'm gonna use today, they will behave the same across the environments, and that will provide you with a consistent user experience. You'll see me discussing about how to build an Active Directory, install and configure SQL Server instances, build a Windows failover cluster, and in the end, to create an availability group. A few use cases for this setup that I personally use is just to build test labs, for example, to explore new options in new versions of SQL Server, for example. Then to do demos like this one today, for example. And also the same approach can be taken to deploy real world environments for example, for clients that I work with. If you have any questions during the presentation, I would ask you to ask them in the chat, and then we will try to answer them at the end of the session. So why would you want to use this approach? So infrastructure as code, like it's an acronym that you hear all the time today. And it's nothing more than replacing the traditional manual provisioning of infrastructure through admin consoles or a GUI with a programming-based approach. So scripts or scripting or however you want to call it. So instead of clicking buttons and navigating through various screens to deploy or enable infrastructure, either if it's on-prem or in the cloud, these actions are now achieved through code. The real benefit of the infrastructure as code are seen when large environments or large number of infrastructure resources need to be deployed. Another benefit of the infrastructure as code usage is the ability to create automation and to integrate with continuous integration or continuous delivery pipelines. That's what everybody wants and should use today to make their life easier. So you want this because you want to have consistency across your environments. You want to be able to continuously improve your infrastructure where you run your code. You want to be compliant and test that compliance all the time on a regular basis. And also everybody knows that automation will ensure that all the processes that you already have in place or supposedly have in place are followed, because then the pipeline doesn't deviate from those. So in today's session, I will show you a lot of PowerShell code. So it's nice if you have knowledge about that. So I'm guessing all of us here have it. It's also good if you have basic understanding of how and what an Active Directory is and how it works and what the role of the Active Directory in an infrastructure, and also to have an idea about VM templates. Usually in enterprise environments, a DBA is not usually involved in building the Active Directory, for example, or building the templates from which the machines are deployed. But nevertheless, it's a good idea to know how SQL integrates it with all the rest of your infrastructure, because you can get an insight of how this ties together and be able to troubleshoot faster and better. For those who want to look at the code that I'm going to show today or during the presentation, feel free to get it from my GitHub account, and you can follow it along with us today if that's what you want. The tools that I'm gonna use today, there will be the three main ones. So it's gonna be Packer. It's gonna automate the creation of virtual machine templates. Terraform to automate the deployment of VMs from those templates. And DBA tools, which is a PowerShell module, a free one, an awesome one. And I'm gonna use it to set up and manage the SQL Server instances, and later to build availability group. This is how the infrastructure that we want to create should look like. So it's a simple infrastructure that can serve as a testing ground for everything that requires an availability group or even an Active Directory. So if you want to play with an Active Directory, you can deploy the same thing or use the scripts in the GitHub repo. Take note that the build of the Active Directory, it's a simple one. It's not hardened. It doesn't enforces best practices. So that's up to you to do. So I will have the Terraform and Packer. Those are the tools on my laptop. And in the GitHub repo, you can find also scripts that will check that you have the latest version available of those tools. And if not, it will download them for you. These tools will communicate with my vCenter in my home lab. For those interested, my home lab consists of 3 Intel NUCs with SSDs, and additional storage is provided from a NAS. So I'll be deploying one VM running Windows 2019 core that's going to be used for the Active Directory. 2 VMs running 2019 core, and they will be our SQL nodes for the availability group. And 1 VM running 2019 with a GUI this time. And that's because we want to use this as a jump host from where I'll be managing the rest of the infrastructure. So I need some templates first, and I need a way to automate their build. Why do I want to have that? Because I need a way to build those on a regular basis. For example, whenever updates are available for the OS. This way, all my VMs built on top of those templates will already contain the updates. So it's easier in the long run. So Packer, it's a free tool that's available from HashiCorp, and it's used to automatically create machine images. Packer uses what they called builders, which are responsible for creating the machines and generating images from them for various platforms. There are separate builders for the cloud or the on-prem, so EC2, VMware, VirtualBox, Azure, Hyper-V. In my case, it's VMware, so I'm going to use that. The image build process will consist of just one command that will point Packer to pick up the build parameters and variables from a few JSON files. So the basic workflow of how this works, it's shown in the picture. At least that's how it works in vSphere, but it will work the same if you deploy in Hyper-V environment or a VirtualBox, for example. So the packer will take the defined source. It's usually an ISO. It's going to create a machine on the builder, and then it's going to execute the provider's defined tasks. And at the end, it's going to generate an output. That output, in our case, will be a template, a VM template. So now let's look at some snippets of code that's going to be used by Packer. We'll also look at the actual files in a second. So Packer will need to know the vSphere server name and credentials. For example, the DC name that's specified in my environment, the data store where it needs to put those templates after it's going to finish the build. I can also specify the admin or root password to be set for those templates. In this snippet of information, we need to give the builder, for example, in my case, it's vSphere ISO because I'm running on top of VMware. The location of where those ISOs are on the data store, the network adapter type, for example, that we want to use for our template. It will also provide, for example, the location of auto unattended XML file that's going to be made available for a Windows OS deployment. Those floppy files, that's how they are called, they are made available to the VM during the build. So in my case, the auto unattended XML file contains the command to run all the rest of the scripts, for example, like enable WinRM, install VMware tools, set a default shell, for example, to PowerShell if there's a Windows core running. Let's have a look actually now at some of those files. So the screen still looks good, right?
Yeah, we see it.
Okay, cool. So this is a JSON file that I built to be able to to create a Windows 2019 core VM template. Sorry. So we see that here that in the variable section, we're gonna give all the details that the packer will need to be able to build and to know where to put those templates at the end. For example, we're going to tell it how to name the template. Like I said, where the ISOs are located. In this case, it's a Windows 2019 ISO. Where the VMware tools for Windows, in this case, ISO is located on the data store. We can also specify the resources that we want to allocate to that template. In my case, I want 1 CPU, 1 gigabyte of memory, and 20 gigabytes of disk size. That's the template. After that, when we're going to deploy the actual VMs, we can change those resources according to our needs. So in the builder section, we need to specify the type of the builder that we want to use. For example, when the builder will run, so after it will spin up the VM, it will wait and then communicate via WinRM, and it will run those customization that we want to do for the template. Yeah, stuff like the storage, network adapters, ISO paths. A nice thing that I like to do, for example, is to put on the vSphere. I like to put on the templates a note to store the date when that template was created. So that's helpful. You notice here that I'm also running a sysprep. The file it's called sysprep. It's not actually a sysprep. It's just a regular PowerShell file that just customizes the Windows OS. It's just stuff that you all do, like, or for example, disable network discovery, set network connections to private, set firewall rules to allow RDP. An important thing, like I mentioned earlier, I'm installing a PowerShell module, PS Windows Update. This will be used again to download all the updates that are available for that Windows OS, and it's going to install them. So all my VMs deployed from this template will contain the update. Setting the page file, that's an important one, and I see a lot of people are missing it, and it's causing issues to set the power scheme to high performance. So you don't want your servers to save some energy. Yeah, so it's just up to you what you want to put here. You don't even need to do it if you don't want it. This type of consideration. Maybe you want to do it later when you deploy the VM. So that's totally fine. I have now a small video that where we can see this process in action. It's not going to be very long. So in my home lab, like I mentioned, when the Packer build starts, it will create the VM and then mount the ISO, in this case, Windows 2019. It's gonna upload the floppy files that we specified, and the installation and then the customization of the OS starts. In the end, the VM, it's gonna be shut down and converted to a template. You can choose not to convert it to a template. It's just gonna be a regular template otherwise. So when all those steps are completed, you can see the VMs will be made available and ready to be used. In my case, if you see the Windows 2019 core one, it has a provision space of 20 gigs. So that's including all the updates, all the OS and everything in it. And it's because I specified that initially I wanted my OS drive to be 20 gigabytes. So now that we have those templates created by Packer, we want to deploy VMs from them, and we want to do this in an automated fashion. So that's where Terraform comes into play. So Terraform will allow us to build, change, and version our infrastructure. That infrastructure can span multiple public and private cloud providers. So you are not tied to one or the other. You can have a mix if you want. We can also use it to manage all our resources, for example, like network appliances, software as a service, or platform as a service type of things. Now, this is how a typical workflow using Terraform would look like. So you see in the left side, the developer will push code to a source control in step 1. Then upon acceptance, the CI/CD pipelines, they will use Terraform to validate the known Terraform state. So that's the step 3. Then it's going to be a plan is going to be formulated against the real infrastructure via the APIs. So that's the step number 4. And then finally, the execution of the plan and then updating the Terraform state will happen. So that's when your resources will be ready. This is the strength of Terraform, that it can interact with APIs. So this means that you can expand the functionality of Terraform and create your own integration if you want. In the continuous delivery part here, you can see you can tie it up into all the tools that are available today, like GitHub, GitLab, in Azure, or for example, if you want to use Jenkins, that's up to you, and many more are out there. So the syntax that we're going to use for Terraform, it's called HashiCorp configuration language, shorted it's HCL. It looks like this. It's relatively easy for humans to read and write because it resembles a JSON, but yeah, I find it easy to work with. Now, Terraform relies on plugins, which they called providers, to interact with the remote systems. In my case, I'm interacting with vSphere, and I'll be using the vSphere provider. So those providers, or each provider, will add a set of resource types and/or data sources that Terraform can manage. So every resource type is implemented by a provider. So with other words, without providers, Terraform cannot manage any kind of infrastructure. That's the role of the providers. Let's now look at some snippets of code used by Terraform. So like I mentioned, in order to communicate with my vSphere, Terraform needs to know the host name of the vSphere, which credentials to use, resource pools that are available for my deployment, which clusters that it needs to put the resources in, where on which data store to put them. For the VMs, I will also need to specify the admin account names and the passwords, which gateway for the network configuration of the VMs, or which DNS servers to use. So that's that. Then I will instruct Terraform to clone an existing template. We're going to have a look at the real code in a second. In this section, for example, I'll define the network configuration settings for the VM, the IP address, the net mask, and the DNS servers to be used. Let's now look at some actual Terraform files. So there is a file that you'll find it on GitHub repo. It has the extensions of tf-vars. So basically, in this file, we're going to place all the variables that we're going to reference in our Terraform files. For example, I'm going to put the vSphere host here, the user, the password. Notice here the name of the Windows template. So that's how Terraform will know which template ID to look for in the files where this is referenced. Again, it's going to know what my gateway is or the DNS servers. So this is the provider vSphere, as I said. So this is the main file, and that's how Terraform gets the information of what it needs to deploy on your infrastructure. So first, it's going to need to create a folder. In our case, I'm going to call it Terraform Lab. And this is the part where I'm going to where Terraform is going to build a Windows VM core. So we want to use a naming convention for our VMs. So I'm going to prefix them with the TF. I'm going to put them on the folder that we specified earlier called Terraform. Like I mentioned earlier, remember our templates had 1 CPU and 1 GB of RAM. Here, I'm telling Terraform to deploy my VMs, and those VMs will have 2 CPUs and 4 GB of memory. So you can do that here as well. Which type of network interface to use, the disk size, size, and how you want them to be provisioned. For example, thin provisioned in my case. This is the template ID that I was telling you about earlier. So this will come from this one. So Terraform will look which template in my my vCenter has this name, and it's gonna know that it needs to clone it. So after that, it's gonna do a customization. So you can do that here as well. If you want, you can change the name again or to put something else, or you can omit this. In my case, I'm going to set a work group, and I'm just going to reconfigure the WinRM service, for example. Also, Terraform has the concept of provisioners. In this case, the provisioner, it's a file, so I would need this file to exist on the VM. And Terraform is going to take it from where my file is residing in the GitHub repo, for example, and it's going to put it on the destination VM on this path. And then the remote exec provisioner will take that file, and it's going to execute it. This one is just a simple script which outputs something into a text file, nothing too fancy, but you can do that as well. So again, it's not mandatory. Again, you can use the same approach for Windows or treat differently Windows with the GUI, or for example, this is a part where I deploy a Linux, an Ubuntu Linux VM. I'm using the exact same type of instructions that I need to pass. In this case, the provisioner would be SSH because it's a Linux system. So we looked at the code. How we use Terraform. Most of the time, we're gonna use the Terraform plan command. That's how we start with. So what happens during this execution? It's Terraform performs a refresh unless explicitly disabled, and then determines what actions are necessary to achieve the desired state specified in the configuration files. This is a convenient way to check whether the execution plan for a set of changes will match your expectation, and this is without making any real changes to your resources. So this is just like a dry run. And then when we're gonna issue the Terraform apply command, this is gonna be used to apply the changes that are required to reach the desired state of the configuration. I have a small video where we can see the action performed by Terraform. It's a recording because in my home lab with the three nukes, it takes around 35 minutes to complete, so it would have been too long for a real-time demo. So yeah, it's gonna be. I've sped up parts of the videos. I don't know if they are showing correctly. So Terraform plan will figure out what work needs to be done to reach the desired state. And then we're gonna run the Terraform apply. So after reviewing the plan, we confirm that we actually want to apply it, and Terraform will start building the VMs. If, for example, some, but not all of the VMs are already created, Terraform will see that, and it will only create the missing ones. That's a nice thing. During this run, I'm going to deploy one Ubuntu VM, two Windows 2019 Core, and one Windows 2019 with the GUI. The Ubuntu one will it's the fastest one because the image it's much smaller compared to the Windows one, and the GUI one again it takes the longest. Like I mentioned earlier, for the Ubuntu VM, once the VM is built, the provisioner uses SSH to make additional changes to the VM if needed. And for Windows 1, the provisioner it's going to use WinRM. When all the VMs are built, Terraform can also show you an output, and you can customize it based on your needs. I will quickly show you how, for example, we can tell Terraform which information to output after the run. So, for example, for my Linux machines, I want to have the instance name and the IP address. The same goes for the Windows Core machines or for the ones with the GUI. So we saw that. Now that we have the VMs created, it's time to start building on top of those. This is how the final picture will look like. You saw this picture in an earlier slide. I use this mostly when I need to test something that will require an environment as close as possible to a production environment, for example. Although I could just install a standalone instance, sometimes I need, for example, to test or troubleshoot applications that make use of readable secondaries. And for that, of course, I'm going to be needing an availability group. Or I need to demo to a dev team what happens with their application when an AG failover happens. Yeah, you can think of all kinds of scenarios that can be useful in. I also like to build this to play with security settings in an environment and learn how to better protect the data at the end in case of unforeseen issues. It's also a good exercise to do just to know roughly how long it's going to take you to rebuild the whole infrastructure from scratch if the disaster strikes. I hope it never does, but you never can be too prepared. So the main activities that we need to be performed are to build an Active Directory, join the computers to the Active Directory. I then need to create group managed service accounts, then install SQL instances and configure them. As a last step, I will create a Windows failover cluster, and finally, having that available, we can start creating the availability group. In the GitHub repo, you will find scripts that I'm using to perform each of these activities. So I've chosen to break them down in separate scripts to be easier to follow. If you choose to do the exercise yourself, you need to change the set variables PowerShell script to match your environment. This this script will be .source in all the other remaining scripts. .sourcing is a useful technique to keep your scripts simple if you have if we are talking about only scripts. Let's see quickly how what the script contains. So it's just a simple PowerShell script. The role of this script is just to be a placeholder for all the variables definitions that we're going to need during the deployment. For example, we need to tell it which host it's going to be the domain controller and its IP address, which of the nodes will be the SQL Server nodes in the end, again, the host name and the IP address, which one will be the management node. For the AD, we're going to tell, for example, the NTP servers that we want to use, the domain name. Notice here that those passwords and also the SA password down here, I'm using those in plain text here. This is fine for my lab, but don't do this in any of your environments, not even in dev, for example. Use solutions like a Vault or even PowerShell credentials module to store your secrets. Don't ever store secrets or sensitive information in files that can be seen or accessed by someone else. So again, don't do it in production. For my home lab, is just fine. Let's continue. So I also need to specify details about the failover cluster. So the name, the computer name object that I'm going to create, and the IP address of the cluster. For the SQL servers, I'm choosing to install named instances and to use those named instances to listen on a non-default port, 10,001 in this case. I'm configuring afterwards the dedicated administration connections to run on port 20,001, for example. Then I'm going to tell it which folders how the folders will be named for the SQL, the SA passwords, like I mentioned. Here we can use a naming convention for the service accounts. In my case, I'm going to create group managed service accounts, but yeah, you can feel free to put whatever you desire in these variables. I'm specifying the collation for my instances, which admin accounts to provision, and then I'm going to tell it where to find the installation files for the SQL. In my case, they are on a sharing on a different VM. Last, I'm going to give the details about the availability group, for example, the name, the listener name, and the listener IP. It's going to be a single one. Like I said, those are the variables that need to be specified in that file. You need to customize it, customize them based on your environment. So the first task, like I mentioned, is to build the Active Directory, to create a forest, add DNS zones, configure NTP, create a key distribution service root key. This is needed for group managed service accounts. Also, your domain functional level needs to be above 2012 to be able to use group managed service accounts. Next up, all the remaining VMs are joined to the domain. Here are just put in the computer OU, but in your AD environment, you usually put those in their own OUs. So that's fine. There's also a script on the GitHub repo to create the service accounts, the gMSAs. Using gMSAs is the recommended approach in an enterprise environment, and I don't see why you shouldn't use it, honestly. As an advice also, even if you use gMSAs, try not to use the same one for all the SQL instances you may have. Keep separate ones for dev, int, prod, QA, staging, and even different ones for each instance. So see, in my case, I could have just used only one for the service account or for the agent, but I'm choosing to use separate ones. So yeah, it's a good practice to have to do this this way. Normally, this next part of our lab build can be done fully unattended using configuration management tools. Tools like Puppet, Ansible, Chef, DSC, you name it. I'm not going to discuss about those in this session, but know that they are tools designed to install and manage software on the existing servers. So for us, Terraform is just the provisioning tool, which is designed to provision the servers themselves and the rest of the infrastructure, like I said, the load balancers, network configurations, and so on. But the job of configuring those servers is better done by other tools, like the ones mentioned here. For our purposes here, I will use DBA tools PowerShell module to install and configure the SQL instances and the availability group. Yeah, it's a module filled with commands, useful commands. It's developed by the SQL Server community. It can help with all the aspects of creating, administering, or migrating your SQL Server instances. If you are not using it already, I'm sorry to say it, but you're missing out. This is the way to do database administration these days. That being said, I've compiled a list of tasks that we will need to perform to reach our goal here. So we're going to install the nodes, configure them, perform some hardening, install some tools, some SQL agent jobs, create new databases, then create the availability group listener, and then check if our SPNs are correct or even set. So we'll begin the installation of with the installation of the two nodes. I'm going to specify the configuration for my SQL installation. So I'm going to tell it stuff like which version in 2019 in this case. The instance name, like I mentioned, I chose to install a named instance. The TCP port, I'm also using a non-default port instead of 1443, so it's 10,001. Those are variables coming from the first script that I showed you. Note that for the SQL instance, I'm going to use an object that's going to expand to the two nodes. So that's how DBA tools will know, and it will install the SQL on both of those nodes. That's going to be done in parallel, for example. I also specify the collation and the accounts that I want to use for the SQL engine and for SQL agent services. I choose to install only the engine feature and use the mixed mode authentication in this case. Last, all I have to do is to pass all this configuration to the install DBA instance commandlet, which again is going to take care of installing the instance using that configuration, those parameters on both of the nodes. And that's how simple it is to install two SQL instances. And yeah, it's done in a consistent way. So now that the installation is completed, we have the instances running, two standalone instances for now. It's time to start to configure them and to apply a few best practices. So now everyone knows that defaults are not really the best ones when it comes to SQL Server. So we need to change some settings like set the max memory, add some trace flags, and so on. I'm going to then rename and disable SA account, configure the model DB, create an utility database. This is, for example, how the code would look like to change server level system configuration. So that's set DB ASP configure. So I can configure stuff like cost threshold for parallelism, enable backup compression, enable optimize for ad hoc workloads, stuff like that. Set DB max memory, it's a nice one. It's going to look at how much RAM there is available on the box, and it calculates the default optimum that it can give to the SQL instance. So this formula it's that's used by the function uses a general recommendation. So it doesn't account for everything that you may have in your environment. But even so, it's way better than the default value, right? The set DBA startup parameter command allows me to enable trace flag, for example, 3226 in this case, which suppresses the successful backup messages in the SQL Server error log. I also like to create a database called DBA, and I store DBA related stuff in it. For example, I installed the SP who is active store procedure in it. Now the configuration is done. So we have those SQL installed. They are configured the way we wanted to. And now we need to apply some hardening. I, for example, like to disable the named pipes. Most of the time, this is not used. Get DBA instance protocol function allows me to do this. Next up, I renamed the SA account to SQL admin and disable it. One line of code here. I like to install all a Hangren's maintenance solution and SP who is active on all my instances. So that's just 2 lines of code. For example, for the maintenance solution, I also pass it the parameter to install jobs. So that's gonna even create the jobs for me. For example, I'm using here the database DBA that I just created. If you omit the database parameter, the default will be the master database. Then we're going to create some SQL agent jobs and schedules. I like that to have a SQL agent job to recycle my SQL Server error log on a daily basis. That's how simple it is to do it. So you saw with a few lines of code, now we have the instances configured the way we wanted them to be. And that's what we need for our availability group next. Before doing that, we need to build the Windows failover cluster though. There's a script on my GitHub repo to build this. Note that this one needs to be executed from one of the nodes that will be part of the cluster, and that's because the new cluster commandlet, which is part of the failover cluster module, cannot be run remotely without CRED SSP authentication on the server computer. There are ways around that. I've even discussed last night with Marco about it, my mentor, but yeah. because I have two nodes in the cluster, I need to use a file share witness. This file share sits on the domain controller, but make sure you don't do this in production. For my home lab, it's accessible. It's acceptable nevertheless. Now we have the Windows failover cluster created. We need to create a dummy database for our availability group. So it's just a testDB database that I'm creating and taking a full backup. The new DBA database command accepts a bunch of parameters that will allow you to specify, for example, file paths for the data in the log files, the growth for the data files and the log ones, and so on. In my case, it's gonna use the model DB. It's just fine for my purpose here. The next step is to tell SQL Server instances that now they are part of the cluster. So enable DBA HADR. It's the command to do this. I'm running it in a for each loop, so that means it's going to be applied to both of my SQL nodes. Now that we have everything, we are able to create the availability group. So under the hood, the command, the new DBA availability group command also grants cluster permissions if necessary, grants endpoint connect permissions to service accounts, and grants create any database permissions if the seeding mode is automatic, like it is in my case. This is done, and we need to now add a listener. There's a function for that. It also supports multi-subnet listeners. You just need to supply the appropriate IP addresses and subnets. Again, the variables are the ones that we define in the first script. Last thing I need to do is to test my SPNs. There's a command for that as well. So test DBA SPN. Everything looked good, but if it wasn't the case, there is also a command to have those set up for us. So the set DBA SPN, it's the function, and it will connect to the Active Directory and search for an account. If the account is found, then it will attempt to add an SPN. So once the SPN is added, the function will also set delegation on the services, unless the no delegation parameter is specified, for example. Take note that in order to run this function, the credential you provide must have write access to the Active Directory. I have a small recording now to show you how this all comes together with the DBA tools. So you see during with the script, I'm installing the SQL instance on 2 nodes. Now this part now it's just grabbing the DBA tools package from the gallery, and you see that it's using 2 threads. So the installation runs on both of my SQL nodes in the same time, and it's grabbing them, grabbing the installation files from the share I specified. That's after that is completed, then all the configuration and installation of the tools happen, like I explained in the code earlier. Now we have all the steps completed. We can just see that all the infrastructure that we needed to build is in place. The availability group is created. DBA tools, it's a huge time server. Imagine how long it would have taken me to build this using T-SQL, right? And some of the stuff you cannot do with T-SQL, for example, like doing those SPNs, for example. So if you haven't already, I encourage you to take DBA tools for a spin and see how awesome it is. I have a few resources for you guys if you want to learn more about what I've just showed you today. For DBA tools, the functions are very well documented on the website. There's also a blog with a bunch of use cases that DBA tools can handle. And also make sure to check out the team page at dbatools.io/team. Most of the contributors have their own blogs where they post a ton of useful information. So grab it from there. That being said, I hope you found something useful in my session today. I want to thank all the volunteers for their hard work. I want to thank the organizers for the opportunity. And I want to thank Marco for his mentorship and his guidance. Any feedback that you may have for me is welcome. So if you enjoyed the session, hit me up on Twitter or LinkedIn. Even if you didn't like it, tell me about it so I can do better next time. Thank you again.
Viorel,
and let's see. Yeah.
Thank you very much. So to all attendees, if you have a question, please use the Q&A so we can ask the question to. I think you explained it very, very, very well. It was awesome. That's what from my side. So hopefully,
Thank you.
What I see in the chat, a lot of people see that the session was awesome.
Yeah.
So if you are not, please fill in the evaluation. I will put in the link in the chat. Like we always say to every session evaluation, we ask a score from 1 to 5. Don't fill in only 5, but also fill in the comment what you like the most of the session, so the speakers can learn from that.
Yeah, I'm mostly enjoying taking the bad comments there because that's how I learn what I did wrong. So
I must say compliments. The demos were running smoothly with the video. The integration with your slides deck was pretty cool. So you had a good mentor, probably.
Yeah, indeed, Marco was really helpful, and thank you again, Marco, for this.
Well, thank you, but I did nothing. The session was great before my intervention. And Viorel, I have a question for you.
Sure.
Okay. Well, you showed us how you can deploy a VM with Terraform with an image prepared by Packer, and then you jump inside one of the VMs and start using DBA tools to automate the creation of a SQL instance. Can you add these DBA tool parts in the provisioning phase, just to obtain a fully working SQL environment without any additional intervention?
Yeah, we can do that, like I mentioned, with the configuration tools. So those will better fit the purpose, tools like Ansible, Puppet, or Chef. I've chose to use DBA tools here because I have the scripts broken down by activities. For example, part of those scripts, you can take them and use them directly in your environment. For example, to set, I don't know, the max memory, you can just copy paste it, it's gonna run. You don't need to build everything before. But again, like you said, yeah, it's not fully automated. If you want unattended automation, it's better to use a workflow with which involves provisioning tools.
Yeah!